In this part of the lecture, we are going to, I am going to introduce some useful tools for vector processing. We will focus on vector files, and we will, of course, use, as always, the files that we have provided you in the geo package. So the first thing, now I share my screen. So, and the first thing to do is to open a new project of QGIS. So I suggest you close the project that on which you were working with Daniele and reopen another project, so that you should see the blank project. And we can also save this new project clicking on Project, Save As, and I suggest you save the project in the folder that contains the data. For example, we can call it vector processing. And we click on Save. Okay, so this is just to save the project. And we can upload the files that we need for the exercise. In order to upload them, we can do the same thing that you have done previously. So click on Layer, Add Vector Layer. And we, in this interface, we click on the three dots and we browse our folder that contains the data. So browse on your computer the folder that contains the data and select the GIS for Schools geo package. Open it. And once you open the GIS for Schools geo package, you can click on Add. You see that all the vector layers are, by default, are selected, so it is correct, and you can click on OK. Now you can close this window. And all of you should see the same thing that I'm seeing now. Please let me know. Okay. I can proceed. Okay. So I see all the vector layers in the Layers panel and also in the map. In the first part of the exercise, we will need only two layers that are the layers lakes and river network. So please turn the other two layers off. For now, we don't need municipalities and temperature. So uncheck them from the layers panel. So you should see only lakes and river network. So the first thing we do now is map digitizing. So we are going to see how to add new features to existing layers. So for example, we want to add another polygon to the layer lakes. For example, we have realized that a portion of a lake is missing, or we need another lake for for the project we are doing. So how can we add a new element, a new polygon element, to the existing layer of lakes? First of all, we need a base map, so a map that allows us to, that guides us in digitizing the new lake. So we can go under Web and click Quick Map Services. We can choose as base map what we want. But I suggest you you choose the OpenStreetMap base map. So go under OSM and select OSM standard. That is the base map that Daniele has shown a few minutes ago. So all of you should see the same thing. The lakes should be correctly placed in the correct position. And imagine that we want to add a new layer to this, a new lake to this layer. For example, the lake that is located here in Lecco area. In particular, these two lakes are called Lake Garlate and Lake Olginate. So the lakes are these two. So first of all, we have to zoom in this area around Lecco. So slowly we zoom to the area of Lecco, around Lecco. And the lakes that we want to digitize are this one, that is Lake Garlate, and this one, which is smaller, that is Lake Olginate. Okay, in order to digitize them, we have to start an editing session on the layer lakes. So in the layers panel, you should right-click on the layer lakes and then click on toggle editing. That is the symbol of a pencil. So click on toggle editing, and once you have done this, you can begin to digitize the lake. In order to digitize the lake, we have to add to the menu two toolboxes that are present in QGIS. So right-click in the empty space of the menu in the gray area, and in the toolbars section, you should check two toolbars. The first one is Advanced Digitizing Toolbar. So check this toolbar. And the other one is Digitizing Toolbar. So please check these two toolbars, Advanced Digitizing Toolbar and Digitizing Toolbar. And once you have selected these two toolbars, they appear in the menu. This is the Digitizing Toolbar, this one, while the Advanced Digitizing Toolbar is this one that I am showing you. Can you load these two toolbars?
Yes.
Okay. Okay. Thank you. Okay. So the first thing we have to use a tool that is available in the digitizing toolbar in order to create this Lake Garlate. So the tool is called Add Polygon Feature. The symbol is this one in the digitizing toolbar. So click on that symbol, and you see that the pointer has changed. In order to create the geometry, you should follow the base map that you have uploaded. And you have simply to click with the mouse every vertex of the polygon. So I suggest you stay at this scale, so you don't need to be very precise. But try to be as precise as possible, but at this scale, click every vertex of the polygon in order to create the geometry. So as I am doing now, I am following the base map in order to recreate the polygon. You can see that Lake Garlate finishes here, where there is this gray segment, which is a dam. And simply by clicking with the mouse, you can digitize the geometry. And once you have finished, so once you have completed to put every vertex of the polygon, in order to finish the digitizing process, you have to right-click with the mouse. So now I right-click, and you see that the geometry is saved. The icon is this one in the digitizing toolbar. It is called Add Polygon Feature. Okay. So if you right-click the last vertex, you should see something like this. You see that a window appears here. And this window allows the user to fill in the attributes of this particular feature. So we have to type the name of the lake and the source. The name in this case is Lake Garlate, or Lago di Garlate in Italian, or simply Lake Garlate. It is the same. And as a source, we can type OpenStreetMap base map. So it is important that you fill the name and the source attributes, as I have done. And once you have written these two attributes, you simply click on OK. And you see that the lake, this new geometry, is added to the layer lakes.
Sorry, can you repeat the last step? And the source is OpenStreetMap.
Yes, the source is OpenStreetMap base map.
I'm sorry. Mine was working, and now it's not. I cannot toggle edit, so it's like shade. I have no idea why.
Allora, did you toggle editing?
I did. I have the menu, but now I can't access it. I don't know why. It's all shaded with gray.
Okay. The digitizing toolbar is shaded.
Yes.
Okay. So can you click on the pencil symbol in the digitizing toolbar?
It's gray. It's shaded.
Okay.
It's not. How do I say it? I think it's not available, and I don't know why. Because it was working, I had it greens and all of that, and suddenly it's just not working.
Okay.
Maybe maybe I clicked something wrong.
Maybe you could try to redo. Right click on the layer lakes and click on toggle editing again.
Okay.
Okay.
Oh, it's working now. Thank you.
Okay.
Thank you.
You're welcome. So, other questions? So it is not necessary that you are very precise.
Is it possible to modify the lake?
Yes. We will see in a minute how we can do it. Okay. So this is the first thing that we see, but I ask you to digitize also the other lake in the same way, exactly in the same way. That is Lake Olginate, which is this one. So again, click every vertex of the lake. And once you have finished, right-click and fill in the two attributes. In this case, the name is Lago di Olginate, and the source is the same as before. So OpenStreetMap base map. When you have finished, you click OK, and you can see that also this other lake becomes blue. So this means that the polygon is added to the layer lakes. Okay. And some of you asked how can we modify the geometry that that we have added, because, for example, we have realized that we made a mistake in the digitizing process. We can do in this way. So first of all, we have to select the geometry that we want to modify. In order to select the geometry, you should have enabled the selection toolbar in the main menu. If you don't have the selection toolbar enabled, as always, you have to right-click in this empty space of QGIS and check selection toolbar. So you should check this option, and once you have done it, the toolbar is this one with these yellow boxes. Okay. So in order to select the feature that we want to edit, first of all, we have to select the layer that we want to edit here in the layers panel. And then we click this tool, select features by area, this one. If we use this tool, we can click on the feature that we want to edit. And you see that the feature becomes yellow. If the feature becomes yellow, it means that we have correctly selected it.
Can you repeat, Alberto, please?
Yes. Okay. Did you enable the selection toolbar, this one?
Yeah. Yes.
Okay. So first of all, click on the layer lakes. Select the layer lakes.
Okay.
Then you can use this tool, select features by area, and then you click on the geometry that you want to edit. The geometry should appear yellow now.
Okay, thank you.
Okay. So now that we have selected the geometry, we can use, for example, these always in the digitizing toolbar. We can use this tool that is called Vertex tool. If you click on Vertex tool, you can change the position of your vertices. So if you have made a mistake, you can change the position of the vertices. For example, if I want to change the position of this vertex, I simply click on the vertex, and then I click on the right position. You see that the geometry has changed. So you simply have to click on the vertex that you want to move, and then you click on the right position. Okay, it is very easy. So in this way, if you have made mistakes, you can correct them. It is a very simple way of doing this. Okay. Now, another thing that I want to show you is how to place a hole inside a polygon feature. For example, Lake Garlate has an island inside Lake Garlate. You can find an island. So we should actually add a sort of hole inside Lake Garlate. Okay, because of course the island is not part of the lake. So we have to remove that geometry from the lake. How can we do this? First of all, the symbology is not actually helpful because the lake is colored in blue, so we don't see the island inside the lake. I suggest you to change the symbology of the lakes. And I recall you that in order to change the symbology, you have to right-click on the layer lakes and go under Properties in the Symbology tab. Okay. In the Symbology tab, you should select this outline blue symbology that is proposed by QGIS. It is convenient because it is not colored, so it is not completely blue, but only the outline. Okay, the outline is displayed, so we can see the base map inside the lake. So if you click on outline blue and you click on OK, you can see that the symbology has changed, and we can see the base map inside the lake. In fact, if you zoom in on Lake Garlate, in the top portion of Lake Garlate, you should see that there is this island, which is called Isola Viscontea. Am I too fast? It is okay? Okay. So there is this island called Isola Viscontea that we want to remove from our geometry. How can we do this? As before, we have to select the geometry that we want to edit. So with the Select Features tool, the same that we used before, we click on Lake Garlate. And you see that the geometry becomes yellow. The boundary becomes yellow. So this means that Lake Garlate is correctly selected. And in order to add this hole, we can use a tool that is available in the advanced digitizing toolbar. So this toolbar, advanced digitizing toolbar, and the tool is this one, add ring. You should select this tool, add ring, okay? And you simply have to digitize the island simply by clicking on the boundary. You see that I am digitizing the island, and once I have finished, I right click. You see that this hole has been added to the feature. Okay, this is a simple way to add a hole inside a polygon geometry. Okay.
Excuse me, Alberto, could you repeat all the process, please?
Yes, yes. So, first of all, you have to select Lake Garlate. And how can you select it? You have to use this tool in the selection toolbar, select features by area, okay? So you use this tool and you click on Lake Garlate. That should become yellow. The boundary should become yellow. And once you have selected the lake, you go in the advanced digitizing toolbar and use this tool that you see in my screen, add ring. Can you find it? You have simply to click on it. And you have to digitize the island. So put a single vertex. Okay, vertex by vertex. You have to draw the island. Okay. Once you have finished, you right click. Okay, you right click and nothing else. Okay. Okay. So now in order to save the edits that we have performed, we have to right-click on the layer lakes. So right-click on it and click on Save Layer Edits. If you click on Save Layer Edits, all the geometries that we have just added are saved. So click on it, and then right-click again on the layer and click on Toggle Editing again, so that we stop the editing session. We have finished to edit our geometries. Okay, so first of all, click on Save Layer Edits, and then click again on Toggle Editing. And all the edits that we have performed should become permanent. Okay. So this is a way to digitize very easily a polygon feature. Now, I suggest you to, you can see that Lake Garlate is still selected because the boundary is yellow. So now, in order to deselect the lake, you should use this tool in the selection toolbar. The tool is deselect features from the current active layer. So click on it, and you see that the selection disappears. Okay.
Excuse me. That's yes. a way to move the map while you are editing it.
Yes, you can do. You can click on the mouse roller.
Yeah.
And pan the map. Or you can also use this pan map symbol that is available in the menu. Okay, if you click on the map on the symbol of the end, you can.
But without losing, for example, the vertex tool.
Okay. Yes, you should click on the roller of the mouse. Yeah. In that way, you don't lose the pointer. So you click on the roller, and you can move the map. Okay. Okay. Or you can also zoom in and zoom out, and in order to move without losing the pointer. It is the same thing. Okay. Okay. Okay, so now we have seen how to modify a polygon layer. Very similarly, we can also modify a polyline layer. For example, the layer river network. So very quickly, we see together how to add a new river in the river network layer. So in the menu, in the layers panel, we should start an editing session, this time in the river network layer. So right click on the river network and toggle editing. Okay, because now we want to add a river to our layer. In particular, we can add a river which is located near Como. The river is in this area that I'm showing you. You should zoom to this area. If you zoom, you can see this river, which is called Torrente Caraello. And we are going to add this small river to the layer. Okay, did you find it? It is in this area on Lake Como. You zoom here and you find Torrente Caraello. It is this one. In any case, you can choose any river you want. It is not a problem. And to add this new feature, we use the digitizing toolbar again. You see that there is this button, add line feature. We use this tool, add line feature. So we click on it. And we simply digitize the river by clicking every vertex. Okay. And once you have finished, as always, you have to right-click with the mouse. Okay. It is the same procedure that we saw before, but in this case for lines, not for polygons. Okay, and here, as always, you have to fill in the attributes. In this case, the name is Torrente Caraello and the source is OpenStreetMap base map. Okay. If you click on OK, you see that the river is added to our river network layer. As we have done before, in order to save the edits and stop the editing session, we right-click on the layer river network, and we click on Save Layer Edits. Then we right-click again, and we click on Toggle Editing, so that the edits are saved and the editing session is stopped. Okay.
Sorry, that's a way to change the attribute of drawed elements.
Yes. You have closed the. You have did you save the edits?
Yeah.
Okay. In order to change them, you should start a new editing session, because every time we make a modification, we have to start an editing session. So again, you should right-click on the layer and click on Toggle Editing.
Yeah.
Then, in order to change the attributes, you should open the attribute table of this layer. You should right-click on the layer and click on Open Attribute Table.
Okay.
If you scroll down the table,
yeah,
you should see that you should find the feature that you want to modify. It is if you click on name, it will be sorted in alphabetic order.
Okay.
So you should find Torrente Carello.
Yeah.
Okay. So here, simply, if you click on Torrente Carello, you can type a new name. Okay. Or similarly, in the source field, you click on the attribute, and you can change the description.
Okay.
Okay.
Yeah.
And as always, you should then stop the editing session. Okay. Now I want to explain how can we access the information that are present in polygon in vector layers, because you know that a polygon layer is characterized by an attribute table. That is a table that contains all the information, all the attributes that characterize each single feature. How can we access this attribute table and this information? First of all, we can access them with the identify feature tools. If you go in the main menu of QGIS, you should find this symbol, the eye symbol with the arrow. Okay, and you have to click. For example, if we wanted to see the information related to this lake, that is Lake Maggiore, you should click on the layer lakes in the layers panel. And once the layer is selected, you simply click on Lake Maggiore. You see that the boundary becomes red. Okay, so it is selected, and a window appears. This window provides you with all the information related to Lake Maggiore. So you can find the name, which is indeed Lake Maggiore, and also the source. These information are the attributes that are present in the attribute table. Okay, so this is the first way to access the information related to a single feature. If you close the Identify Results window, okay, and I let you see another way to access the same information. You can open directly the attribute table, okay, of this layer, simply as you have seen previously, simply by right-clicking on the layer lakes and clicking on Open Attribute Table. Okay, you can see that the attribute table is characterized by a series of rows. Each row corresponds to a single element. So, for example, a row is present for Lake Maggiore, another row is present for Lake Como, and so on. So each single row corresponds to one geographic element. And each column is a field. Okay, is a field that contains all the attributes related to the features. We can also modify the attribute table. So, for example, we can add a new field that contains a new information related to our feature. How can we do this? In order to add a new field, as always, we have to click on the pencil symbol, which is toggle editing. Okay, so in the attribute table, you click on the pencil symbol so that you start an editing session. So you can modify the features of this layer. In order to add a new field, you should click on this symbol, new field, that is present in the attribute table. So click on new field, and we give a name to this field. For example, we want to calculate the area of each single feature. So this new field will be area, the name will be area. And we also have to select the type of the field. In this case, you can understand that the area will be a real number. So we have to click on the arrow symbol and select decimal number real. So once you have given a name and you have selected the type, you click on OK, and you see that the new field appears. Okay. Did you manage? Okay. So the problem is that the area is null. So, okay. The problem is that now the area is null. We want to fill in the attribute, okay, the area of every single feature. We can do this with QGIS, with the field calculator. So we have to use this tool, which is called Open Field Calculator. If you click on it, with this window, we can fill in all the attributes. In particular, we have to check update existing field, because we want to update an existing field, a field that we have already created. So we check update existing field, and here we have to select the field area, because we want to modify this field. And in order to calculate the area, we have to use this tab, okay? And in particular, we have to expand the section geometry, clicking on the arrow geometry. Okay, so we expand this section, and we double click this line, area, with this dollar symbol. If we double click this line, you can see that here in the expression tab, the same name appears. Okay. And once you have finished, you click on OK. You see that the area field has been filled in. So the software has calculated the area in square meters of every single lake.
Sorry, Alberto, but I have a little problem, because when I'm trying to open the attribute tab, actually another Windows is appearing, and I don't know why. Is different from is a sort of filtering section, and lakes will appear in a yellow, with a yellow border. I don't know why. Yes, this table is not appearing.
So you don't see this table?
No, I don't see that table.
It's very similar.
It's slightly similar, but it's not exactly. I don't have all the list of the lakes. I don't have all that things. I just have one lake.
Okay. So I ask you one thing. Is there a lake that is selected?
Yes.
A lake is yellow?
Yeah.
Okay, you should deselect the lake in this way.
Okay.
You go in the selection toolbar, and you click on this symbol, the select features.
Okay, just so. No. Okay.
And now the lake shouldn't be selected.
Okay. Good. Okay. And then open.
Now you should click on the pencil, toggle editing.
No, prova ad andare proprio sul pencil.
Toggle editing.
No, vai su.
Okay.
You should add a new field.
No, aspetta, tasto destro.
Okay.
No, vai su open, quella lì di prima, attribute table. No, okay.
There's something wrong with my. I'm sorry, but yes, you can go on with the lesson because.
Questo qua, vai a add attribute table. Secondo me devo fare. No.
No.
Can you see the same thing I am seeing?
No, I'm sorry. But anyway, you can go ahead with the lesson. I'll check in the document. Don't be. It's not a problem.
Okay.
Okay.
E cambia la definizione, se messo di così.
I don't know why.
No,
Okay. Maybe we can make a break then.
Okay, I got it.
Okay.
Yes, is that small icon in the.
Is it like a table or like the structure?
Yes, is the other. Okay.
Okay. Perfect. Okay. So now that you have filled in the area field, As always, we have to save edits, clicking on this symbol, save edits, and then you have to stop the editing session, clicking on the pencil symbol. Okay, and the edits you have performed now are saved. Okay, so a new field is present and it is filled. Now, very quickly, I let you see how the different options that QGIS makes available for the selection of features. So we can, in order to select a feature, for example, a feature belonging to the layer lakes, we have to use the selection toolbar. As you can see, we have many options. Okay, we have not just a single tool, but we have 4 different tools. The first tool that we have used a few minutes ago allows us to select the feature directly clicking on the map. So if you use the select features by area, you simply click the element on that you want to select on the map. Okay, and that element becomes yellow, or at least the boundary becomes yellow. But there are other ways to select features. In particular, we can use this second tool, okay, select features by value. If you click on this arrow, we can select features by value, or we can also select features by expression. What does it mean? If we click on select features by value, this window opens, and we can say, for example, select all the lakes that have an area greater than a certain number. So, for example, in this area section, we can, for example, write 10 million, so 7 times 0, 10 millions. And here, in the tab next to the area, we click this tab, and we click on greater than. We check greater than. Okay. So 10 millions greater than. If we click select features, the software selects all the lakes that have an area greater than 10 million square meters, of an extent of 10 million square meters or more. Okay. And you can fill other things. So you can also say, I want these lakes with this extent, but also coming from a particular source. So if you type the source you want and click select features, only the features with those characteristics will be selected. Okay, so for example, I can type in name Lago Maggiore, and if I click select features, you can see that only Lake Maggiore will be selected. Is it true? It is a smarter way to select features based on the values of their attributes. Okay. Okay, if we close this window, we can deselect the selected features with this tool, okay? Because I want to show that there is another way to select features that is always with this arrow, and the tool is called Select Features by Expression. So if we click on it, we can type here an expression, okay, in order to select the features. For example, we can select only the lakes with an area greater than 10 million square meters. How can we do this? In this section, in this panel, we expand the geometry section, okay, and we expand the fields and values section, okay, and we double click the field area. You see that area appears in the expression section, and we type greater than 10 millions. Okay, if you type this expression, you click on Select Features, you can see that, again, only the lakes with area greater than 10 million square meters will be selected. And of course, you can type whatever expression you want, you like, okay, using the fields that are provided in this section, okay. As always, we deselect the selected features with this tool, because I want to introduce the other possibility, that is select by location. We have to use this tool, Select by Location, that you find here. This tool allows the user to select features based on their position. For example, we can select the municipalities, okay, in the municipalities layer, we can select only the municipalities that intersect the lakes. How can we do this? We have to specify here in Select Features From, we specify municipalities OpenStreetMap. Okay. We check intersect, the intersect box, and here, by comparing to the features from, we select lakes. In this way, only the municipalities that intersect lakes will be selected. Okay, so if you click Run and you close the window and you turn the layer municipalities on, okay, you should see that in yellow, only the municipalities intersecting the lakes are selected, have been selected. We can also close the base map because we don't need it anymore. So uncheck the base map. You see that in yellow, only the municipalities intersecting the lakes have been selected. It is okay? Okay. Okay. And now this is why did we do this?
Excuse me. I receive an error that tells me in particular that as GIS for school geopackage lakes as invalid geometry. Please fix the geometry or change the processing settings. Is an error in drawing the lake, or change the processing settings to ignore invalid input features option.
Okay. So when you try to select by location, this error.
Yeah, yeah.
Okay.
It tell me feature 13.
Feature 13. Okay. Probably there was an error in digitizing that feature. Feature 13 should be Lago di Olginate.
Yeah.
Or Lago di Garlate.
Open attribute table.
Open attribute table.
Originate, yeah.
Olginate. So try to do this. Toggle editing. Select number 13, the row 13.
Yeah.
And use this symbol, delete selected features. So try to delete that geometry.
Delete feature. Okay.
Delete selected feature. Then
no, a moment. Sorry. Delete. Well, I don't find it.
This is the symbol I'm showing you.
In the table.
Yes,
oh,
yes.
Yeah. Sorry. Okay.
So
open attribute table.
Okay.
13. Okay. Okay.
Delete.
I did it.
And once you have deleted,
I can
click the pencil and save. It will tell you save edits, and you click yes.
Yeah. Okay. Well, I retry.
Okay, but first you should deselect.
Okay, it's okay.
It's okay.
Yeah.
Okay. Okay, so you all should have this selection. I was telling you that the selection is only temporary. So if we close our project, we lose, of course, this selection. In order to maintain the selection, we have to export these selected features. So create a new file, okay, that contains only the selected feature. How can we do this? We have to right-click the layer municipalities and click on Export, Save Selected Features As. Okay, so we are exporting, we are creating a new file with only these selected features. The format is as a shapefile. Okay, that is the typical format for vector files. Then you should enter a file name. You click the three dots here, and you browse to your usual folder, GIS for Schools folder, and you call this new shapefile municipalities on lakes. Okay. You click Save and OK. You see that a new layer that is colored in purple, in my case, should appear. It is the layer that contains only the municipalities that intersect the lakes. Do you agree?
Please, can you repeat the steps?
Yes. So once the municipalities are selected, you right-click on the layer Municipalities, OpenStreetMap, click Export, save selected features as. Okay?
Okay.
Okay. Now, you specify as format Esri shapefile. Okay. And if you click on these three dots symbol, you have to go in your folder that contains all the data we are using, okay, and enter the name Municipalities on Lakes. Once you have entered this name, you click on Save, and then on OK. And this new layer should appear. Okay? Okay. Now, another thing that I want to show is the join operation, because until now we have used only geographic data, or better, geospatial data. But generally speaking, many data that can be used in our projects could not be geospatial. For example, we can use also tables, and in particular the table that we want to use and from which we want to extract the information is the table population, which you should have in your layers panel. If we open this table, so if we right-click on this table and click on Open Attribute Table, you can see the content of this table. This is a table that contains the name of the municipality, the name of the province, and the number of inhabitants of each municipality. Okay. We cannot actually use directly this table in QGIS because it is not a geospatial data. But we can add the information that are present in this table to an existing layer, to an existing geospatial layer. For example, we can add this information to the table municipalities on lakes, to the layer municipalities on lakes that we have just added. How can we link these two elements, population and municipalities on lakes? We can link them with a join operation. In order to create this join, we have to right-click on municipalities on lakes and go in the properties tab. Okay, municipalities on lakes, properties. And we have to go here in joins. Okay, so now we create a join between municipalities on lakes and population. In order to add this join, we have to use the plus symbol that you find here. And we have to specify some information related to the join. So we want to join municipalities on lakes with the table population. So here, where you find join layer, you click on population. Okay. And we have also to specify the field that will be used to make this join. Okay, we have to identify a field that is in common between municipalities on lakes and population, and the table population. And the field that is in common between these two layers is the name of the municipality. So in join field, we have to select nome com, that is name of the municipality. In the target field, we click on name. Okay, these are the two fields that are in common between municipalities on lakes and population table. Okay, based on this correspondence, QGIS will make a join operation. So once you have completed this part, you click on OK, and then OK again. Now, if we open the attribute table of municipalities on lakes, so right-click on municipalities on lakes, and click on Open Attribute Table, you can see that some fields have been added. So the initial table contained only feed, source, and name. But now 3 additional fields have been added. And these are the fields coming from the table population. Okay, if you scroll the table, you should see the correspondence. Okay. Did you have problems? No? Okay. So this operation is very useful because we have added additional information to our original layer. In particular, now we have, for each municipality, we have the information related to the number of inhabitants. Okay, you can also see that in some cases there is this null. This means that QGIS didn't find a correspondence between the two layers. And the reason is that these two data come from different sources. So they are not, there could be some problems. But in any case, you can see that in most cases, the correspondence exists. So for each municipality, you can find the province to which it belongs and also the number of inhabitants. Okay. And as for the selection, also the join is only a temporary operation. This means that if we want to save this join, the only thing we can do is to export a new file. A new file that will contain the join. So you have to right-click on municipalities on lakes, export, save features as. Okay. So the format will be as a shapefile, again. And the file name, if you click on the 3 dots, as before, you should browse to your folder that contains the data, and you should enter a new name for the new file. We can call it municipalities on lakes population. Okay. So we click on save and OK. you see that this new layer appears in the Layers tab. And this layer contains the permanent join, the permanent link between municipalities on lakes and the table population. In fact, if you open the attributes table of this new layer, you can see that the 3 new fields are present and they are permanent. Okay, they are saved inside this file. But you can also see that by default, QGIS has given a name to these new fields that is not quite significant. It is useful to change the name of these fields because otherwise we can't understand the meaning, the content of these fields. How can we change the name of these fields? We have to use a tool which is available in the toolbox. So in the menu of QGIS, go under Processing, Toolbox, and we search a tool that is called Refactor Fields. It is this one, so double-click the tool. And with this tool, we can change the name of the fields as we want. So the input layer will be municipalities on lakes pop, because we want to edit, to change the names in this layer. In particular, we want to change these 3 names. How can we do this? We have simply to double-click on the name that we want to modify and type a new name. So the first one, GIS for School, call it feed2. The second one is the province, while the third one is the population. Okay, so now we are giving a new name to these 3 fields. It is a more significant name, so you can understand what is the content. Okay, and now we have to save the new file, as always, the file that will have this name. So with the 3 dots.
Excuse me, can you tell me how to open Refactor Fields window?
Yes.
I lost it.
Yes, you should, in the main menu of QGIS,
yeah,
you click on Processing,
yeah,
Toolbox.
Okay.
And this window should appear. You have to type here, Refactor Fields.
Okay.
Then you double click.
Okay.
This window appears, and now you have to specify the input layer, municipalities on lakes population, and you have to change these 3 names. Feed2, province, population.
Thank you.
Okay. And then we have to save this new file. So we click on the 3 dots. We click on Save to File. And in the usual folder, okay, we call this new file simply municipalities. Okay. And then you click on Save, Run. And close. You can close the window. Okay, so we have this new file, this new layer, that is municipalities. If we open the attributes table very quickly, you see that the fields have an appropriate name. Okay. Okay. So now there are problems. Okay, I think I have half an hour, and I am finished. Can you follow me, or do you want to have a break of 5 minutes? It is the same for me. Can we go ahead? Okay, 20 minutes, and I finish. Okay. Okay, so now I wanted to show you 3 tools that are available for vector layers. They are called geoprocessing tools for vector data, and you find these tools under in the menu under vector geoprocessing tools. We see 3 different tools that are buffer, dissolve, and intersection. These are very useful tools for all the operations related to vector layers. Let us start with the tool dissolve. What is the tool dissolve? The tool dissolve allows to merge together different features belonging to a certain layer. For example, we want to merge together the municipalities that belong to the same province. So starting from this layer of municipalities, we want to get to another layer that has a lower number of features because the municipalities have been grouped together based on the province to which they belong. In order to do this, you have to go under Vector, Geoprocessing Tools, and select Dissolve. It is very, very easy, this tool, because you have simply to specify the input layer, in this case, municipalities, it is correct. And we have to specify the field on which the dissolve operation will be based. In our case, we want to dissolve the municipalities based on the province. So we click on the 3 dots and we check province. Okay, so we check province, we click OK, and nothing else. We have to simply save the output, the new file. So, as always, click on the 3 dots, save to file, and in the usual folder, we can type municipalities on lakes dissolve. Okay, so we simply give a name, we click on save, and then run. So if we close the window, you see that municipalities have been grouped, okay? So based on the province, you can see it. Okay, did you follow me? It was a very simple tool, but it can be quite helpful in the processing of vector data. Another very simple tool is the tool intersection. And what does this tool do? This tool is used to extract a portion of a layer that intersects another layer. So, for example, we can extract only the portions, only the segments of the river network that intersect the lakes. So if I zoom, you can see that there are portions of the river network that intersect the lakes. Okay, here you can see them here, here, and so on. So how can we extract only these portions of rivers? The tool that we can use is the tool intersection. So under vector geoprocessing tools, we click on intersection. In this case, it is very simple, this tool, because you have simply to specify the input layer that will be a river network, because we want to extract the portions of rivers. Then we have to specify the overlay layer. In this case, it is lakes, because we want to extract the river network that intersect lakes. Okay? And then simply the only parameter, the only option that you have to check is the position of the output file. So here in intersection, you click on the three dots, save to file, and as always in the usual folder, we type a name for this file, which is, for example, river lakes intersect. We click on save and then run. If we close the window, okay, in order to see this layer, you should move it at the top of the layer panel, because otherwise you can't see the result, because it is covered by the other layers. So if you move it to the top and you zoom, you can see in my case in brown, you can see the portions of rivers that fall within the lakes. You see them? Only the portion of rivers intersecting lakes have been extracted. Okay. Then the other tool, the other geoprocessing tool, is the tool buffer. What is the buffer tool? The buffer tool allows to create a respect area around a specific geographic element. For example, imagine that we want to generate a respect area around the river network. Okay, for example, a respect area of 50 meters. The tool that is available on QGIS is called buffer. And you can find this tool under vector geoprocessing tools buffer. Okay. There are two types of buffer. We can use, for simplicity, for now, we can use a fixed distance buffer. That is, the respect area will have always, for every river segment, will have the same distance. How can we do this? We have to select input layer river network, because we want to compute the respect area around this layer. And here, where you see distance, you can write the distance in meters, okay, of the respect area. For example, in our case, we can write 50, so 50 meters. Then you have to check the solve result. And finally, you have to save the output. So here, you click on the three dots, save to file, and in the usual folder, we write river network buffer fixed, because it is the fixed distance buffer. Okay, we click on save and run. Now the software is computing the respect area. It will take a while, few seconds. And once it is finished, we close the window and we see the result on the map. If we zoom to the river network, you see that in blue we have the rivers, and the respect area around the river has been computed. Okay, so we have a respect area around each river segment. And the length, the distance of the respect area is exactly equal to 50 meters. If you want to check, you can use this tool, measure line, this tool here. We click on the river and on the boundary, and you can see that the distance is actually 50 meters. You can see in the window, the distance is 50 meters. Okay. Okay. Did you follow me? Okay. Okay. Another possibility is to create not a fixed distance buffer, but a variable distance buffer. What does it mean? It means that the respect area will not be equal for every river segment. But, for example, we want a respect area that is larger for very long rivers, and a respect area that is lower for shorter rivers. Okay, this could be an example. And how can we do this? For example, first of all, we have to modify, we have to edit the river network layer, because we have to introduce in this layer the information related to the length of the river network. So first of all, open the attribute table of the layer river network. As always, right-click, open attribute table. We want to add a field that is the length of every river segment. You should be able to do this because we have done this previously for the lakes. But I repeat the procedure. You have to toggle editing in the attribute table, clicking on the pencil symbol. Then you should click on new field, on the button new field, and enter the name, in this case, length. The type can be decimal number real, because the length of the river is a real number, is a decimal number. So we click on OK, and you see that the new field is added here. We have simply to fill the attributes, the value, with the field calculator. So click on Open Field Calculator. Check Update Existing Field, and select the field length, because we want to edit this field. How can we calculate the length? In this section, we have to expand the section geometry, clicking on the arrow. Okay, so we expand the geometry and we look for length. You should find this length with the dollar symbol. So double click it and click OK. You can see that the length of every river segment has been calculated. Are there questions or everything is okay?
Okay.
Okay, thank you. Okay, so now we have to add another field which is called distance, because in this field we want to specify the distance of the respect area. So again, click on new field. The name will be distance and the type is whole number, integer. Okay, so you click on OK, and we have to fill in the values of distance. First of all, we want a distance equal to 50 meters for rivers with a length higher than 50 kilometers. So first of all, we should select only the rivers that have a length higher than 50 kilometers. How can we do this? We have to click on Select Features using an expression. This one. And we should write the expression length higher than 50 kilometers. How can we do this? We have to go under Fields and Values. So we expand Fields and Values, and we double-click Length. Okay? And we type higher than 50 thousandths. So 50 kilometers. Okay, length higher than 50 kilometers. We click on Select Features, and we close the window. You see that if you scroll the table, only the rivers with a length higher than 50 kilometers will be selected. Okay. And for these rivers, we want a distance equal to 50 meters. So we open the field calculator, update existing field, we check update existing field, and we click on distance. And we write in the expression tab, we write 50. Okay. We click on OK. You see that in the selected, for the selected rivers, we find a distance equal to 50. Here and here. Now, for all the other rivers that are the shortest rivers, we want a distance that is equal to 20 meters, okay, so a lower distance. So first of all, we have to select all the other features, all the other rivers. And the best way to do this is to use the invert selection tool. You can find here, always in the attributes table, if you click on invert selection, you see that all the other features have been selected. Okay. Now we open again the field calculator. We check update existing field, and we click on distance. This time the distance will be equal to 20 meters. So we write here 20. We click on OK, and you see that the field has been filled. Okay. Okay, now we have finished. We can save edits. We click on Save Edits, and we click again on Toggle Editing. So we stop the editing session. Now we deselect everything, clicking on this tool. How can we put only 2 decimals? Let me check. You can actually you can specify the type of the field, and based on the type, the software automatically calculates the value. You can specify decimal number, and in this case, you find all these decimal numbers, or the other possibility is whole number, integer, meaning that you don't have any decimal, okay? Only the integer part of the number remains. There are no other possibilities. You have only these 2 possibilities. Okay. Okay. So if you have deselected all layers, clicking on this tool, we can make the last step, that is calculate the buffer, so the respect area, based on the river length. Okay, so a different respect area based on the river length. So again, we go under Vector, Geoprocessing Tools, Buffer. We specify as input layer river network. And here in the Distance tab, we go here in Data Defined Override. So we click here, this last button. We go under Field Type, and we click Distance. This means that the buffer area will be calculated according to this distance that we have specified. Okay, so click here, Field Type, Distance. You have to click this. And nothing else. You should only save the file. So click on the 3 dots, Save to File, and we can call this new file River Network Buffer Variable. So save, run. Okay, so click on close, and the result is visible here in green. You can see that this buffer distance is larger than this one because this river has a higher length. So it is longer, so the buffer distance will be higher. Okay, but the concept is the same as before. Okay. Okay, last step very, very fast, and we have finished. Are there questions? Did you follow me? I know that this last part was not very easy, but I hope you could follow me. And in any case, you can find the detailed description on the website, in the book. You can find every single step, so you can try on your own to redo everything. Okay, the very, very last step is the rasterization. What does it mean? This means that we can convert a vector file into a raster file. Okay, the file that we want to convert is the temperature distribution file. So my suggestion is that you uncheck all the layers because we don't need them anymore. The only layer we need is temperature layer. Okay, so it is the only layer we need. And this is a layer of points. In fact, if I zoom, you can see that there are many, many points, and each point represents a single value of temperature. We want to convert this vector file, this point file, into a raster file. The operation is very simple because you have only to go in the menu under raster, conversion, and you click on rasterize, vector to raster. Okay, so in this way we convert the layer into a raster layer. Okay, the input will be temperature, GIS for schools, GeoPackage temperature. We have to specify the value. We have to click under field to use, and we click on value. What does it mean? This means that the value of temperature will be used in the raster. So the value of temperature, which is stored inside the points, will be converted into a raster. The other parameter that we have to specify is the resolution, so the spatial resolution of the raster. That means we have to specify the dimension of the pixels of the raster. So the output raster size units, we click on it and we click on pixels because we want to specify the resolution in pixels. We can specify the horizontal resolution, that is the horizontal length of the pixel and the vertical length of the pixel. The best value, I have made some trials, and a good value is 1000. So you can type here 1000 for the vertical and for the horizontal resolution. In any case, in order to find the value, there is not a correct value for the resolution. It depends on your purpose. You should make some trials until you reach the best solution. I have made a few trials, and 1000 is a good value. You will see in a while. Finally, the output extent. We have to specify the output extent. So you click on the three dots. You click on calculate from layer, and you click on temperature. This means that the raster will have exactly the same, will cover the same geographic area of the layer temperature. Okay, so click on it, And the only other thing you have to specify is the position of the new file. So here under rasterized, you click on the 3 dots, save to file, and in the usual folder, we type temperature raster. In the usual folder, we give this name to the raster. So we click on save, run. If we close the window, you can see the result. So first we had this layer of points. Now this layer has been converted into a raster layer. And by the way, in the afternoon, you will see with Chiara how to manage raster layers, raster files, because in my lesson, I have introduced only vector layers and all the operations that we can do with vector layers. Chiara, in the afternoon, will explain you how to manage raster layers. Okay. There are questions? Otherwise, I have finished.